the inverse of a 2 by 2 matrix is quite straightforward. We said if you've got a 2 by 2 matrix given like A, B, C, and D, maybe call it M. What you know is the determinant of M is what? Is AD minus BC, isn't it? And to find the inverse of M is 1 over the determinant of M. Then what do? You interchange the main diagonal elements. So this is going to be D and A. Then you put negatives on the minor diagonal elements. This is going to be minus C and minus B like this. So it's a pretty easy method to find the inverse of 2 by 2 matrix. Now, a 3 by 3 matrix has got, it's not possible for us to do the same. So we've got to divide it into a set of determinants, which we call into a set of what? Minors. Okay, and I've already explained how we can find a minor of a number, isn't it? Of an element. So we're going to find, so the first thing that you have to do is to find the determinant of A. That's what we did here. Then the next thing is you find a matrix of the minors of A. So you've got to create a matrix of the minors of A. So the symbol M is used for the matrix of the minors unless this causes confusion with another matrix in the question. So you can use M unless there is a confusion with the matrix itself as M. In forming the matrix, each of the 9 elements of the matrix A is replaced by its minor. Show you what that means, because perhaps it may not make sense. Okay? I've also explained from the matrix of minors, you form the matrix of cofactors by changing the signs of the sum of the elements of the matrix of minors according to the rule of alternating signs illustrated by this pattern. I think I explained this rule of alternating signs. Positive, negative, positive, positive, negative, positive. Okay, you leave the elements of the matrix of minors corresponding to the positive signs in this pattern unchanged. You change the signs of the elements corresponding to the negative signs. You write the transpose of the matrix of cofactors. We're getting there, okay? A transpose is simply when you replace the row with the column, okay? The row becomes the column, the row becomes the column. Then the inverse of the matrix is going to be given by the formula 1 over the determinant times the cofactors of T, the transpose of C, which is that. It may not really make sense right now. Okay? I appreciate that fact because there's a lot, I mean, no one wants, especially if you're a mathematician, no one wants to read a lot of words in between when they're trying to do a question, isn't it? All right, but let's make some sense to it now. Can I move on? Why is it? It says from the matrix of minors, form the matrix of cofactors by changing the signs, form the matrix of cofactors by changing the signs of some elements of the matrix of minors, according to the rule of alternating signs, illustrated by this pattern. And I said this method, we only use it if in your 3 by 3 matrix there is an unknown variable. But if there is a non-variable, you don't need to go through these 5 steps. You just need to punch into the calculator the matrix and get your inverse immediately. Are we together? But when we are doing the systems of equations, you need to understand these things. Okay. All right, let's move on. Now, a good example would do let's have this example. Find the inverse. So let's follow all the steps. Step number 1. In the first step, we have to calculate determinant of A, isn't it? So we've got to find determinant of A. And the determinant of A, like yesterday, we said we alternate. It's always easier to use the first row. Positive, negative, positive. So I'm going to start with this minor 1 and write the cofactor of this minor 1, which is what? 4 minus 1, 1, and 0. This is a minus, so it's going to be minus 3. I'm going to write the cofactor of 3, 0, 1, 2, 0, isn't it? Then this is a positive of 1. I'm going to write the minor of 1. The cofactor is what? 0, 4, 2, minus 1. Then I'm going to find the determinant of A, which is just going to be 4 times 0 here, minus, so you're going to have 1, 0, plus 1, minus 3 is plus 1, it's minus minus. Oh, yeah. Then you're going to have minus 3, this is 0, 0 minus 2, isn't it? Then you're going to have 1, this is 0 minus 8. Then you find the final answer, which I believe it will just be minus 1. So you now have the determinant. Okay? You go to step 2. We said you form the matrix of minors. You form that. We said you what? You form the matrix of minors. Okay? So the matrix of minors, you use capital letter M. So what are we doing? We start with the minor of 1. What's the minor of 1? We have it here, isn't it? It's what? 4 minus 1, 0, and 1. Agreed? Agreed? What's the matrix of the minor 3? It's 0, 1, 2, 0. What's the matrix? What's the cofactor? These are cofactors of the minor 1. That's 0, 2, 4, minus 1. So I'm forming a matrix of minors. So which means I also have to find the cofactor of the minus 0. What is this 0?
It's negative because it's across as well.
What do you mean?
So plus, minus, plus, and then.
No, we're not doing that yet.
So you see for the first one, you put 1 on the bottom, the
For this one,
Yeah.
it's 4 minus 1.
And then
1.
0.
Yeah, thank you. It's 1 0 here. We'll do the alternating of signs later. Right now, we're just forming a matrix of minus. So if the matrix of 0 here is what? Becca, do you see where we're getting it? You just go to 0, you do this. You're left with 3, 1, minus 1, and 0. All right? It's not that is okay. Then you look at the matrix, the minor of 4. 4 is what? It's like this, right? 1 1 2 0. 1 1 2 0. Then 1 is like this, which is what? 1 3 2 minus 1. Okay, go ahead and do the matrix, the minor. Do the last column. What is the minor of the element 2? 3 1 3 1 4 1. What is cofactors of the minor minus 1? 1 1 0 1. Then the last one 1 3 0 4. That's step number 2. So you create a matrix of minors. So obviously it's a big matrix like this. You might want to simplify it. That's all. Is it? How would you simplify this? You just say 4 the same way you do the determinant. So this is 4 times 0 minus 1. So this is going to be 1. Quickly go through it. So these are the minors that we have. So what's the first element, the first column? Column, I'm talking of column. It's 1 1 minus 1.
Yeah.
Then
Minus 2 minus.
Then
Minus 8 minus 4.
Good. So that's step number 2. We now have a matrix of minors. We move on to step number 3. Step number 3, what are you meant to do? So you find the matrix of cofactors. Adjust to make, what should I say? Adjust to make a matrix of cofactors. So when you are now making a matrix of cofactors, what are we doing? We're just changing the what? The signs. So what does it become? You're following this order. Minus, hold on, yeah, that's minus, positive, minus, positive, minus, positive. So in this case, let's use C. C becomes what? This remains positive, right? Then minus 1, correct? Then what else? The next one?
So it remains minus 1.
It remains minus 1. Then you go to the next one. It becomes 2. It remains minus 2. Minus 1. The next one, it remains minus 8, 7, 4. This is a matrix of cofactors. Happy? So you use C, you form a matrix of minus, then from there, you form a matrix of cofactors. Cofactors, you're just adjusting with the signs. You're just adjusting, you're alternating the signs in this order. All right? Then you go to step 4. What are we doing with step 4? Write the transpose. Write transpose of C, which is CT. C with a superscript T. So when you're writing this transpose, like I said already when Marx asked, the row becomes a column. So the first row is 1, 2, minus 8. It becomes a column 1, 2, minus 8. The second row becomes a column. It becomes minus 1, minus 2, 7. The third row becomes a column. It becomes minus 1, 4. Happy? Okay? Then you go to step number 5. Step number 5 is saying the inverse of A is 1 over determinant of A times CT. You get that? So we have got CT, which is here. And what is 1 over D? 1 determinant is minus 1. So it's going to be 1 over minus 1 times 1, 2, minus 8, minus 1, minus 2, minus 1, minus 1, minus 1, and 4. Obviously, this is a minus, so it has to affect all the elements. You simplify. That's the inverse.
Wait, then there's 7 and like the bottom middle.
Is a 7. Okay. It's looking like a minus 1. Yeah, it's a 7. So where there is all these negatives, I can write it here now. So the answer is A inverse, because 1 divided by minus 1 is minus just. So this becomes minus 1, minus 2. This was a minus, right? So it becomes 8. This becomes 1, 2, minus 7, 1, 1, and minus 4. That's the inverse. Okay. You follow these 5 steps. First step, calculate the determinant. Second step, form the matrix of minors. You look at the minors, form that matrix of minors. Third step, you adjust to make a matrix of cofactors. You adjust the signs. So you just adjust from the matrix of minors, you adjust to make a matrix of cofactors. It is the one that has got this number, the adjusted signs. Then from there, you transpose the cofactors. Then you are done. All right. Next question. Quickly write it down. So, like I said, this method is very handy when it's what? When we've got unknowns in the matrix. So what do we do to find, we have been told there is a condition, K is not equal to 0. So we go straight away to step number 1. Step number 1 is calculate determinant. So I can write calculate determinant. That's Taylor who says I should write like this, not DETA, isn't it? Let's calculate determinant of A. Determinant of A is going to be equal to, I'm using the first row. So this is positive, negative, positive. So the element 3, the cofactor, the minor of element 3 is just K, 0, minus 3, and 3. Then the next one is minus 2. Then it's just going to be minus 2, 0, minus 1, and 3. The last one is positive, but the number itself is negative. So it's still going minus 2, then minus 2K, minus 1, minus 3. Once you get the idea, it's not even difficult to pick up the minors of every element. Did you see that? Once you just get it, it's not even difficult to pick up the elements, to pick up the minors of each element. So it's straight away like this. Then you simplify. This is 3 in bracket 3K minus 0. This is minus 2 in bracket minus 6 minus 0. Then this is also minus 2 in bracket minus 2 in bracket. That's going to be minus 2 times minus 3, that's 6. That's minus K, but there is a minus again, so it's going to be minus. So this is 6, right? Not negative 6, but just 6. So that's going to be 6 plus K, plus K. So that's going to be 9K.
As a whole, it's just down to 11K.
Sorry?
Goes to 11K, but it's 9K, then it's plus 12 minus 12. Okay. Oh, yeah, minus 2K, so it's actually 7K.
So the answer is 7K. Oh, you are just ahead of me. Okay, good. So the determinant is this is 7K. All right? So that's the determinant. Next, we form a matrix of what? Minus. Form a matrix of minus. You can use capital letter M unless the matrix itself was also M. So the matrix of minus is just to pick the minors of each element. There are 9 of them. And if you have seen the format, it shouldn't be difficult to pick them all. So the minor of 3 is here, is K, 0, and minus 3 and 3. The minor of 2 is also here. It's minus 2, 0, minus 1, and 3. The minor of minus 2 is here. It's minus 2, minus 1, K, minus 3. Then I'll go to the minor of minus 2. The minor of minus 2, which is going to be straight away like this, is 2 and minus 2, 2 and minus 2, minus 3 and 3. Then the minor of K, is going to be what? Your K rule like this. So it's 3 and minus 2, right? 3 and minus 2, and then what else? Minus 1 and 3. Then the minor of 0, as it is going to be 3 and 2. I'm going row by row. Then what? Minus 1 and minus 3. Then I'll go to the last row. The minor of minus 1, which is quite straight away, is just 2 and minus 2, K and 0. Then we look to the minor of minus 3, which is just 3 and minus 2, and minus 2 and 0. All right? And then the last one is minor of 3, which is just 3 and 2, minus 2 and K. That's your matrix of minors. You simplify it. That's what you're going to do. So if you're doing such questions, because such questions, they come with marks like 8 marks. You've got to, once you do this, you have obviously have to run again and check if you've not make mistakes, because it's possible to make mistakes, isn't it? So you have to make a check to see if there are no mistakes. So if there are no mistakes, this is going to be 3K. This is going to be 6. This is going to be K plus 6. Because 6 here and K plus 6, yes.
Minus 6.
No.
It is minus 6. It's minus 6. It's minus 2. And then you're not taking.
Yeah, you're right. It's minus 6 here. Minus 6, yeah. Because it's minus 2 and 3. Yeah. That's minus 6. Yeah. Then next one.
0.
It's 0. It's clear. It's 0, right? 6 minus 6, yeah. Minus, yeah. 6 minus 6. Next one. Yeah. This is going to be minus 9. Minus, yeah, so that's minus 7. Next one.
Okay.
Next one. I'm here. Minus 4. Then this one. Okay, good. All right. Next step is to create a matrix of cofactors. Create, or rather, just correct term is form a matrix of cofactors. So you're not doing anything new. You're just taking this matrix of minors and alternating the signs. That's all, isn't it? And out. So the first one is positive, so it remains 3K. Then the 0 is not affected. Then this is not affected as well, because it's positive, negative, positive. Then the next one is negative. So because it's negative, it's going to become 6 here. 6, then what? 7. The other one is, it remains K plus 6, right? Then the negative becomes positive. Then the last one becomes, it doesn't change. So that's your minor that's your matrix of cofactors. Then from there you go to C transpose. C transpose, the rows becomes the columns. So this is going to be 3K, 6, and K plus 6, 0, 7, and 7. Okay? Then 2K, 4, and 3K plus 4. That's what the word transpose mean. Okay? Make sense? So what is the determinant? Therefore, no, not the determinant. What is the inverse? Therefore, the inverse of A is 1 over determinant, isn't it? Which is 1 over 7K in brackets transpose, which is 3K, 6, K plus 6, 0, 7, 7. Since we don't know anything about K, we leave it in terms of K in this case. Happy? Taylor, are you happy? Mm-hmm. That's all. It looks like it's a complicated step, but it's not at all. It's not at all. It should take you around 5-7 minutes to complete a full question.
So can you just leave it like that then with the K outside, or do you have to time everything inside?
You are free to do that if you want to, but I would not bother myself. Given what's inside the matrix, I would not even bother to do that. Unless there was a K appearing on every element, maybe. But given what I see here, I would not even bother to cancel out the case. But you are free to do that. Just not make mistakes, because remember, like when you get to this one, the K are going to cancel, but it's going to create 6 over K. Do you see that? You would want to write that. So I would rather leave it like this, unless there were K's appearing in both sides. Yeah. All right. The matrix A given by that, and the matrix B, and the matrix B is such that AB is that. Okay, cool. So show that A inverse is equal to the same. So in other words, the self-inverse. So if you want to show that A is that, what's another way of showing this? Because if you look at it, if you want to show that A inverse is the same as A, this is the same as showing this. If I multiply everything with A here, remember what we were doing yesterday, this becomes A inverse is equal to A squared. But what is this? It's I. So if we want to show that A inverse is equal to A, it's the same as showing that A squared is equal to I. Because if a matrix is self-inverse, so it's the same as showing that A squared is equal to I. So you can write it as part of the notes, proving A is equal to A minus 1 is equivalent to proving A squared is equal to I. Okay? And how can you show that? You can actually, before you do this, so actually what you do is, you have to show that A squared is equal to I. You have got to go through these three lines. So once you do this, you can now prove like this. You understand? There's no need for you to do anything, because yes, you can punch into the calculator, but there's no evidence that you've punched into the calculator. Otherwise, you have to do all the steps I've given you to show that A inverse is this. Are we together? So if you don't want to do that, you just have to show this statement, then you prove that A squared is equal to I.
Well, how can you say A times A minus 1 is A? If you actually times them,
what do you mean? We have this statement, right?
I know, but how is it?
You have this statement, right? Then what are we doing? You multiply A here, you multiply A here. Hold on a second. You multiply everything with A, right? What does this become? I. What is A times A? A squared.
Oh, it's because you're multiplying.
Yeah.
Okay.
So but you need these steps.
Yeah,
You need these steps. Before you do this, you need to write, actually there should be 3 steps, not 2. You need to write this step first. Then you say, I'm going to multiply this is equal to A times A, which means this I is equal to A. So proving that A is equivalent to that is the same, is equivalent to proving that I is equal to A squared. So let us look at A squared now. A squared is the same as saying minus 2, 0, 1, 3, 1, minus 1, minus 3, 0, 2, minus 2, 0, 1, 3, 1, minus 1, minus 3, 0, 2. And when we are multiplying matrices, we said the row multiplies the column, isn't it? So we are going to have minus 2 times what? Minus 2 times negative 2, which is what? 4, plus this times this, then 3 times, which is just 0, then minus 3 times minus 1, which is just minus 3. Let me just write it, then we'll simplify later. Minus 2 times 3, 6. Oh, minus 6 actually, isn't it? Then 3 times 1, that's 3. Then minus 3 times minus 1, that's just also 3. Then the next one, minus 2 times minus 3, that's 6. 3 times 0, that's 0. And minus 3 times 2, that's minus 6. You go to the next one, 0 times minus 2, that's 0. Plus again another 0, plus another 0. Okay? That's another 0, plus 1, plus 0. That's another 0. That's another 0. And that's another 0. Okay? Last row, that's minus 2, plus a 0, plus 2. That's 1 times 3, that's 3. Minus 1, minus 2. The last one, that's minus 3, 0, and 4. So you can simplify this and check what you get. You are going to get 4 minus 3, that's a 1. This is going to be a 0. This is going to be a 0. This is going to be a 0. This is a 1, 0, 0, 0, 1, which is equal to I as required. Okay? Are we together? That is required. You go to B, find B inverse. So to find B inverse, you're actually given AB. And what is AB equal to? If you good, it's not A but B, right? Remember what we did? You start with B inverse, A inverse, like that. Or maybe I can, to make it easier for you, I can actually start by writing B inverse, A inverse is equal to AB inverse, because I want to make B the sub of the formula, isn't it? Do you understand that? So if I want to make B the sub of the formula, I'm going to multiply what? A on this point here, isn't it? So I'm going to put A on the next to the inverse. So which means I'm going to have AB inverse times A on this point here. So that this gives us B inverse is equal to